got sound. We're good to go. All right. So we are picking it up here at what we call permutations with repetitions. Imagine that the letters of the word book are written on tiles. And when I say written on tiles, try to imagine, like, ever play Scrabble? For those of you who have never played Scrabble, Scrabble is a game where you have letters of the alphabet on these little wooden tiles. I believe to start the game you pick 7 tiles, and then you have to build words out of them. And you build them in the form like a crossword puzzle. So if you put down the word C-A-T, I have, maybe I have the word, I have a T, a W and an O, I can then put, whoops, apparently I haven't played Scrabble in a while. I can put 2 that way, and then you have the letters N and E, you could go that way, and then you just keep building the game. You get points based on how many letters, how long your word is. Different letters are worth different amounts. Try to picture Scrabble tiles. Imagine that the letters of the word book are written on tiles. We wanted to rearrange the tiles, and Ms. Cox, who wrote these notes, said, hey, have you ever noticed that Kobo is a permutation of the word book? Kobo is the name of a device that you can read on, like a Kindle. How many arrangements are possible? Okay, so let's think about this. I'm going to actually write this one kind of longhand. I have the word book, B-O-O-K. But wait a minute. This is a tile. This is a tile. I'm actually going to. This is tile. I'm going to call this tile O1, and this tile is going to be O2 because there's 2 different tiles, but they are different tiles, right? They're different objects in my hand. And I want to rearrange the tiles. How many arrangements are possible? I got to ask you, is this a different arrangement? And the answer is yes, but it's the same word. So it's B-O-O-K like that, and then it's B-O-O-K like this. And then, of course, it's also B-O-K-O. But again, I could write that with a 1 here and a 2 there, or a 2 there and a 1 there. Right? I could switch where the different O's are, and I haven't changed the word any. But it didn't say how many words are possible. It said how many arrangements are possible. So I got to keep counting. There's all the ones where B is first and O is second. What about where B is first and K is second? Well, I could go B-K-O-O, or I could say B-K-O-O. 2 different arrangements. And, okay, what about B where the O is second? Oh, wait a minute, I've already got that. Never mind. I've already got B and then O is second. I guess I'm kind of out of things where B is first. B and then the first O, B and then the second O. Then B and the K. I think that's all of the combinations where B is first. What about all of the combinations when something else is first? How about we put the K first? So that could be K, B, O, O, or it could be K, B, O, O. And it could be K, O, B, O, or it could be K, O, B, O. I know what you're thinking. They both say Kobo, and you're right, but they're 2 different arrangements of the things that I have. Now, where are we at? Oh, I guess we could start with the O. We could have O, O, B, K. We could have O, O, K, B. We could have, what else could we have? We could have O, O, B, K. We could have O, O, K, B. Have I run out? Am I out of arrangements? I'm legitimately asking this question because I actually
you didn't finish the K's.
I didn't finish the K's?
You can do K-O-O-B.
Oh, you're right. I didn't finish the K's. We could have Koob, K-O-O-B, K-O-O-B. Am I done now? Does every single letter get 6 possible things? Have I got all the O's that are possible? No, I don't. Know what I don't have? I don't have OKOB. So I could have OKOB or OKOB. Now do I have them all? I honestly don't know. Okay. What am I missing? How would I check? Oh, somebody's written in the OCOB and OCOB. I've got OCOB. Oh, I don't have OBOC. You're right. I don't have OBOC. I need OBOC. OBOC. 1, 2, and OBOC. 2, 1. How would I do a check? What did I learn yesterday is the number of ways to arrange these 4 letters. Shouldn't it be 4 times 3 times 2 times 1? Shouldn't the actual number of these be 4 factorial? Do I have 24? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. What am I missing? I got OCOB, I got OBOC, I got UBK, I have UK. What have I not counted? OKBO. There it is. Oops. Whoa. OKBO. OKBO. And OBKO. OBKO. And OBKO. 1, 2, 2, 1. I think that takes me to 24, right? I was 4 short. So there we go. 24. We're done. Equals 24. Phew. Now that we've written them all out, and wasn't that exciting, notice that many of the arrangements are identical, right? It doesn't matter in Scrabble, or in just speaking in everyday English, if I move the 2 letters of book, it still says book when I switch the O's. So although I have 4 factorial permutations of the tiles, the 2 O's means that there are 2 non-distinct versions of each permutation, right? For every book, there's another book. For every boko, there's another boko. For every ubk, there's another ubk. Ubk, ubk. Right? For every single word I spell, there's another way I can spell it thanks to the fact that there are 2 O's. So, my number of distinct permutations, distinct means make different words, is 4 factorial divided by 2 factorial. In general, a set of objects N with A objects that are identical can be arranged N factorial divided by A factorial ways. To make it even more general, what if there's multiple things that are identical? In which case, the number of objects divided by the product of the factorial of the number of identical objects. Let's do an example and you'll see what I mean. How many different arrangements can you make using the letters of the word Manitoba? Well, Manitoba has 1, 2, 3, 4, 5, 6, 7, 8 letters, which is 8 factorial. But there are 2 A's. Those A's are identical letters. Are there any other letters that are identical? No. So that's it. 2 factorial. Why am I dividing by 2 factorial? Because 2 A's are identical. And I don't know if I can do 8 factorial divided by 2 factorial in my head. That would be 8 times 7 times, oh, let's try it. I don't feel like reaching for all those calculators. 8 times 7 times 6 times 5 times 4 times 3. 56 times 120, no, 12 times 30. 56 times 360, I gotta reach for the calculator, I don't know what that is. 8 factorial divided by 2. 20,160. different ways to arrange the letters in Manitoba that will be different ways, right? When I say different ways, there'll be different words. How many different arrangements of all of the numbers of 81,818 can you make? Well, let's see. There is 1, 2, 3, 4, 5, right? It's a 5-digit number. So that's because there's 5 digits. And then I'm going to divide by 3 factorial because I have 3 8s, repeat, times 2 factorial because 2 1s, repeat. That one I can do without a calculator. That's 5 times 4 times 3 factorial divided by 3 factorial times 2 factorial. This divided by that is 1. And 2 factorial is just 2, right? 2 times 1 is 2. So the answer to this is 10. There's an example of the type of question where I would not let you have a calculator, whereas number 1, I think I probably would let you have a calculator for that one. How many different paths can you follow from A to B if you can only move up or right? Oh, I love these problems. They used to always throw these problems on grade 7 and 8 Gauss contests. This is almost a classic Gauss problem. And the reason why it's on a math contest is so we expect you to be able to kind of think this through logically and get an answer. If you tried to count them all, boy, you could count a while because, okay, I'm allowed to move up or right. So I can go like this. I can go up here, up here, up here, up here, up here, and over. Or, different color, I could go over, then all the way up, then over, right? Think about how many paths there are. The only thing I can't do, here, let me pick a color here that you can't use. The only thing you can't do is you can't do something like this. Go up and then down and then over and then up. You can't. How come you can't do that? Because you can only move up and right. So can't move down. That's a bad move. Okay, so undo those green moves. They're bad, 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 bad. There. Okay, so now, how many of these paths am I going to have to count? Well, here's something that they all have in common. Notice that the red path that I just drew here, how many times do you move up? You move up 3 times. How many times do you move to the right? 1, 2, 3, 4, 5. You move right 5 times. Look at the blue one. How many times do you move up? Here, here, and here. How many times do you move over? Here, 1, 2, 3, 4, 5. Notice it wouldn't matter which path you took. Every single path you took will be, here, I'll make a new one here. This one's purple. Every path you took, let's just make sure we're right about this hypothesis of mine. Let's go that way, then that way, then that way, then that way, then that way. 1, 2, 3, 4, 5 right, and 1, 2, 3 moves up. Every single path I possibly take following the rules is the same number, so I'm actually, of moves up and same number of moves to the right. So you know what I'm actually asking you to do? I'm asking you how many arrangements I have of this word. How many different ways can I arrange moving up 3 times and right 5 times? So the answer to that would be, that's 1, 2, 3, 4, 5, 6, 7, 8 factorial over 3 factorial for the U's and 5 factorial for the R's, which is 8 times 7 times 6 times 5 factorial divided by 5 factorial times 3 factorial. Those cancel. 3 factorial is 6. My answer is 56. And we'll stop there for today. All right. What if you just went, well, if I just went right, I'll never get to point B. And once again, counting the path, 1, 2, 3, 4, 5 right, 1, 2, 3 up. No matter how I slice it, that's how many moves I got to make. And that would be one of the arrangements of those letters. Okay, so that's my little lesson for today. Let me stop my video. And once again, we're quizzing tomorrow, like I